So welcome everyone. I'm really happy that this Swarm Summit is happening. This is an event that we long been waiting for. It started this series of the Swarm Orange Summit. It started last year. It started that as a kind of team cohesion session for our team internally, and we thought that some people of our team lived in Berlin, so we have it in Berlin. And since there are a lot of people in the Ethereum domain that live in Berlin, we kind of invited them over. And one thing followed the other, and it turned into a little mini conference with 3 days of talks. So this year we kind of shot for that directly and made the event not invite only, but actually public and free. So I'm very happy to see the huge interest. We have an amazing program of 3 days of talks and the Friday hackathon, which you are very welcome to submit hack proposals for that we're gonna choose from. Or if you have a full team that with enough people to work on an idea, then you're also welcome to contribute. So a few logistic things. You find merchandise in the right side of the room, like there's t-shirts, and please use badges like this, so that you can be kind to other people and they know how to address you. It's just nice. And first of all, a big shout out to our hosts, Data Fund, who made this event possible, and the venue Polygon to host us. So big round of applause to Data Fund. And as you see on the branding wall, we have sponsors. Let's thank our main sponsors, Mainframe. Thank you. Thanks to Status for sponsoring audio visuals and recording talks and hopefully doing some post-processing so that make it available for posterity. So thanks to Status. And I want to mention the other sponsors. Infura co-founded Asset and Economy. And Economy is inviting us for a speakers dinner on Wednesday. So the venue to be revealed. Please come and join us. Otherwise, there's going to be kind of free mingling every day anyway. So we're going to have plenty of social occasions to meet and chat. We have a full program for the 3 days. We kind of expect people to stay on after the talks if they like and join our more focused brainstorming meetings. We see how it evolves. The whole program is ideally built up so that more towards the morning we have the kind of more formal and scheduled talks, and as we approach the afternoon, we kind of after the talks scheduled we open it up to discussions and maybe we're going to have like specific topics that we have a panel around or some brainstorming session. We're going to announce that too if that happens. So I would like to say a few things about the Swarm project. That's just as a way of introduction. As you all know, the scope of the project kind of somewhat shifted and extended over the time. Swarm has always been part of the Ethereum Foundation's roadmap as one component of the so-called Holy Trinity of applications. What does this mean? So as the public blockchain was conceived of as the central processing unit of the world computer, so like global secure processing like a virtual machine that allows for secure computation in a global network, you could just as well conceive of Swarm as the hard disk, or as the data layer for that word computer. This was the original analogy. Now, so that made us soon realize that you could basically redesign the entire internet and go back to the first principles of the web to have decentralized services, a proper decentralized internet. This approach was termed Web3, and this is the kind of vision that we were following up on when we doing work on Swarm. And basically this approach needed us to define the scope as base layer infrastructure for Web3. So base layer infrastructure is, for example, in the context of human settlements, I would say that base layer infrastructure is something like the electricity system, the pipelining. In the same way, I think it would be nice to give some sort of scope or definition what I mean by infrastructure, base layer infrastructure services for the web. This definition is best approached if I first kind of ask the question, in today's world, when you see a real-time interactive web application, what kind of services developers typically need, and what they use kind of servers for. So there's various aspects of web applications. First of all, like the rendering of the assets and the web page, where these assets and kind of the data is hosted. How can you organize and what kind of tools you use for real-time data feeds or messaging, for example, troll boxes, chat boxes in applications. How do you handle consensus-critical business logic? How do you make that transparent and third-party provable? Usually, in the world of Web 2, most web applications use some sort of UI which communicates with the database backend, and that database is sitting on a server. So let's talk about these parts in detail. You also have a very important ingredient, which is handling access to certain pieces of data, and authenticate users to have authority and permission to change certain states in the application's logic. These days, you have to have since most services involve some sort of payment or exchange of goods online. You have to have payments and payment guarantees, and these kind of services and transactions are supposed to be these days like first-class citizens in any real-time web application. And of course, finally you can use servers for all kinds of resource-intensive computation, aggregating data, like aggregating usage statistics, and do all kinds of calculations, or for example, media transcoding, etc. So the agenda to provide base layer infrastructure services for Web3 is only hopeful if we have answers to all these areas and provide proper decentralized distributed technologies to cover all these aspects. And the more we can cater for an application stack that developers are used to in the current web best practices, the more chances we have that there's going to be some adoption of this technology. Now let's look at rendering. So rendering is already typically done on the client side. There's more and more examples where you see like, Node.js and all kinds of client-side frameworks to handle rendering and quite sophisticated controller logic. And this trend is really aligned well with Swarm and with generally distributed and decentralized storage, because it allows for static files to be served to clients and kind of outsource or delegate part of the computation needed to render a web page on the client side. Now, Swarm is able to host these static assets, and even the JavaScript that allows for client-side dynamic rendering. It can be hosted on Swarm, but we also have to provide for other components. So we're going to have database services which are decentralized, and for this we're working together with a company called Walk, who's building the database API and the data structures underlying this, and it's going to use Swarm, and hopefully it's going to be integrated in the POC 4 release. We already have the current version of Swarm is already supporting decentralized messaging system and data feeds. It's a component that's called PS or PSS. It's PSS PS because it's a combination of bzz and whisper, which is shh. So it's basically the sound of the swarm whispered. Why is it? Because it combines the cryptographic layer of Whisper, the Whisper messaging system, and the deterministic routing that's underlying this Swarm data delivery. So that messaging system provides you with a sliding scale of anonymity, a sliding scale of darkness. It provides sufficiently guaranteed sender anonymity, but also receiver anonymity up to the extent of the user needs. This is done basically by partial addressing. So when you route messages from one node to another node, then you have the opportunity to reveal the destination address fully, in which case you get the most efficient deterministic routing, but you reveal the recipient, or you can just partially reveal part of the destination address, which is analogous to like sending a letter to my friend, like saying that the address is Budapest, and I'm not specifying the street. So when it reaches Budapest, it's just basically gossiped around, and finally it will be picked up by the real recipient, which is identified by the fact that they are the ones who can decrypt the message. But this kind of gossip broadcast in the vicinity of the destination makes sure that the actual recipient is not revealed, and it's left in the dark to a certain extent. So this messaging system is PSS, which also stands for Postal Services on Swarm, because based on this underlying protocol, you can design a lot of higher-level communication protocols, which we really hope are going to evolve slowly. So one major contributor to this agenda is mainframe and full status, and we're going to hear about them. So the actual infrastructure component PSS, Louis Holbrook is going to talk about it tomorrow, I believe. And you're also going to hear a talk about mainframe's application that's on it, and we're going to hear some practical instructions about their system soon. Are you guys ready for that? Okay, cool. So just two more things I mentioned. So I mentioned the database backend, which is going to be provided as a decentralized and trustless system, which is a big deal because this is the kind of last component which is difficult to see how to eliminate servers from in the application stack. Now, if you have an opportunity to kind of just shout it out to the world, to the network, that you need a database with certain data fields, and you need them to be indexed in this and this way, and then in a trustless system, if there are service providers which promise to provide these indexer services and for example data aggregation, then you don't need to incur like server costs and database maintenance costs anymore, and still have a very secure service through a trusted network. So this can bring down the costs of infrastructure needed for technology supporting your business considerably, which in the long run we hope that this will basically lower the barrier of entry for businesses to have like a more equal opportunity to have the same technology tools as people with a lot more seed money has. So this kind of a bigger picture of allowing more broad, like a wider access and easier access to basic communication protocols, basic hosting solutions, and also payment and all kinds of financial instruments. So this brings me to the last component, the so-called swapsware and swindle framework. This is our take on payment channels, and it's a suite of smart contracts on the Ethereum blockchain, which is kind of integrated with the Swan network code, and allows for certain service networks general service networks to provide certain services. The participants in these networks kind of commit to the rules of their service, rules of the game, as we say, through a contract where they register with a stake and a deposit, and these rules are specified in a way that once they take on a task or a request or even subscribe to constantly provide a service, then whenever they fail to do so, they fail to comply with their promise, this can be proven by a challenge on the blockchain. And either they are required to refute this, or the challenger is required to submit positive evidence that of their wrongdoing or cheating. And these kind of challenges lead to verdicts through a blockchain as a judge type of paradigm, whereby the end of which, if they have a guilty verdict, which means that they didn't comply with their service guarantee or promise, they basically have their stake confiscated, have their stake forfeited, and therefore they suffer the consequences of this punitive disincentive to play foul. So this kind of service level guarantees can be built in and have a very easy interface to handle, and hopefully the micro accounting that's also usually relevant to when these microservices are providing, for example, database indexing or for example, storage insurance in terms of, in the case of files. This can be financed with this kind of peer-to-peer micro-accounting system, which is the swap networks and the swap promissory notes. We're going to talk about this in, Ralph is going to talk about it, I believe, today, later. So once again, to wrap it up, we provide quite a wide range of very important base layer services that hopefully are the substitutes for the usual common web stack used today. They provide more powerful and hopefully cheaper and more democratically provided they're given these implementations which provide a more distributed and more decentralized alternative for these services. So once again, these are hosting, so virtual hosting in a serverless network. There's real-time data flow, so basically the backend for chat and data feeds. The Ethereum blockchain itself provides, of course, the infrastructure for consensus-critical business logic through smart contracts, and Swarm provides database backend, also provides access control through encryption and access control lists to sensitive and private content. Through the swap, swear, and swindle paradigm, it provides a kind of payment and accounting support for service networks and in general digital service provision, and by this basically allows to serve as a new web stack for the decentralized internet. So our plan is quite ambitious, and these are the components I talked about. Now let's move on to quickly recap the status and roadmap of the project, because I want to keep it short. There's a lot of interesting and important talks. So at the moment, we are in the middle of releasing the POC3 release of Swarm. This is a major milestone in our work. This will contain a much more resilient network, and it contains a completely rewritten network layer for the client that we're building. We changed the hashing algorithm to a binary Merkle tree hash, which allows for very efficient, like bandwidth efficient and solidity friendly inclusion proofs. Inclusion proofs play a very important role in making for example, the database services trustless, because they can be used to prove index inclusions in a very compact way. The POC3 release will contain other important features. What we already talked about half a year ago, it contains fuse integration, so it allows for a Swarm manifest to be mounted as a local file system, and you can use this as basically as a Dropbox. So this can be a backend to a Dropbox-like application. It contains the messaging system PSS that we already mentioned. There's a very interesting and innovative solution for mutable resource updates. We're gonna talk about this on Thursday, I think. It's as well. Okay, so mutable resource updates by Luis tomorrow. So mutable resource updates are basically a tool which is similar to the Ethereum name system, which allows you to attach like versions to a semantically integral entity like a website or a domain, and have the notion of updating it with new versions. And this scheme allows you to track that version and have the latest or any particular version of it without resorting to the blockchain, and therefore it saves transaction costs and potentially allows for more frequent updates than the block time would allow. So much about the preview of POC3. Maybe a bit of practical information. So currently we have the POC3 release candidate running on the open test cluster that we have. We call it the staging cluster, as opposed to the production cluster, which is still a testnet, but the production cluster is running the code that's part of the official Go Ethereum repository, and the open staging cluster that we recommend to you to use for hacking and trying things out. This is kind of open now to developers. This is running the newest POC3 version, which you can reach through the Ethersphere repository. Just to mention with a broader context of this. Broader context of the POC releases. What does POC3 represent, basically, on our roadmap? In principle, we have one more release planned, with the POC4, which we intend to mean as the beta release for the production use of Swarm. We would like to get it done by Q1 of 2019. We see how it goes. That release will complete the intended feature set of Swarm by providing redundancy support using erasure coding. It will contain the storage insurance using the crash proof of custody, and also kind of a scan and repair mechanism by which insurers. This keeps on switching off. I don't know why. Yeah. So the scan and repair mechanism, which allows insurers to basically monitor the availability of files and depending on their damage, it allows them to repair and to recover certain lost chunks in a file based on the erasure coding redundancy. So that's going to be a very important feature to have like a reliable and persistent storage system which is resilient to kind of attacks of like basically dropping off certain proportion of nodes in the network. If you have sufficient protection with the erasure code, sufficient redundancy, then these kind of attacks are not hurting the system so much. Luckily, because of the uniform distribution of chunks, you can calculate these parameters quite correctly. So you can have like a attack model of what you think is a realistic investment for someone to knock out a proportion of nodes, and given that attack, you can calculate what degree of redundancy the insurers will typically need to inflate the files to, so what kind of storage overhead is acceptable to have that level of redundancy, which is resilient against node dropouts to such an extent. So these kind of properties will need to be worked out carefully. So is the actual incentive system, which ultimately makes the system, makes the platform economically self-sustaining. So we have a lot of things to do. I think we go in the right direction, and hopefully this summit will provide a very inspiring 3 days and 4 days of hacking, and it will spawn a lot of very fruitful collaboration. And I really thank you for your enthusiasm and courage to use our technology and to delve into such an innovative but at the same time very risky project. So thank you, and enjoy the rest of the week.